This is the recording for the pre-unit assignment 1 and the homework 1. So I clicked on lectures and homework, and then I clicked on unit 1 metric system in motion. And let me get rid of the sidebar here. So what you will find in each unit is the activities and assignments that you have to do. So read through the textbook here, do the pre-unit assignment, and the pre-unit assignment basically is just to make sure that students have looked at the book. It's really straightforward and simple. Homework quiz, do the homework quiz. That's more involved because that's while we're doing the unit over a couple of weeks or so, and there's quite a bit posted there that you have to work on. Work through the suggested computation problems. They actually feed in here into the homework quiz. Notice that I have recordings of them, I have PDF files, and I will also cover them in class, and they're going to be on the homework quiz, and they're going to be on the practice test, and they're going to be on the proctor exams. So you will see these computation problems over and over again. Then there's a supplementary book, which is actually very little to do. Or some reading. It's just on the side. We actually don't use it in class. That's what I mean to say. I should take this one out. These days we're not doing something for the homework with the PHET, which stands for Physics Educational Technology Applets. They're very instructive, but they're actually not on the homework. But what is on the homework are the mechanical universe videos that you would have to watch. Learning objectives. The way that you see each of these units here is that as I'm posting my stuff in my assignments in Blackboard. We're advised to do this here, so here are the assignments, and then these are the learning objectives, what you should get out of each unit in this case. So this one is about kinematics and its acceleration, velocity, and related subjects. Okay, then this one here, this is the first minor assignments, pre-unit assignment. Again, it is about that I make sure that you have looked at the book before you come to class, and it should be straightforward of what you're filling in here and showing me that you have looked at the book. And this one here is recordings that I have posted. Notice that it is funneling into the per-unit assignment, but as I'm going to record that as well, you will see that I probably will actually give that away to you. Homework quiz. Now this is the biggie here. So besides the practice test and the proctored exam, the homework quiz has a lot of points attached to it. So here you have to really work a lot on it with solving physics problems and whatever is posted in there. How to solve physics problems. So please look at this one here, this Word document, and then the kinematic equations, where they come from, and so on. Notice also that I put here, see also homework quiz 1, question 5. So this is where it's funneling into each of these homeworks. Notice from one semester to the next semester, that could be off by a count of 1 or so if I put something in or take something out. So it is question 5, but maybe it's question 6. Oh well. And then these are my recordings, and again, these two here feed into the homework quiz. Apparently I have quite a few homework questions regarding these here. And these are my recordings on YouTube, where I do a lot of the algebra, but you still have to plug in the numbers. And then I have the same printed out here, and then these are extra worked out problems on top of these here. So you have kind of like almost a solution manual, except I believe for some of them you still have to plug in numbers. And again, this one here is the extra book that you should read on the side, and then here's the mechanical universe videos that you would have to watch, and then this is an extra folder which does not go into the homework quiz or any assignments. It's just for your information. I believe actually I might have like an extra credit question on one homework or the other. All right, and that's my little introduction here to the pre-unit assignment and the homework. This is what you would have to do, and then I'm going to go into a little bit more detail on the two. This is the recording for the Unit 1 pre-unit assignment for metric system and motion. So the idea behind this is that you're looking at the book before you come to class. So these here you should be able to solve them by looking in the book. So for question 1 in chapter 1, there's a particular problem here about a golfer, and then I give away the solution, and you have to match these up here. So what are the physical quantities? Well, the distance r and the angle theta. What are the units? Meters and degrees. Significant figures. Well, there are 2 of them. There are 2 given, and so the results also need to be 2. So this is a correct answer here. By the way, this one is incorrect. Please read through it. I'm sarcastic on this one here. So you skip this answer, obviously. Graphical vector addition. Well, that's what happens with vectors. And computational vector addition is when you split the vectors into x and y components, add them separately, and then put them back together using the Pythagorean and the tangent. And that would be what you should get out of chapter 1. Pre-unit assignment for the kinematic equations from chapter 2. There are how many equations? And when you look that up, there are 4 such equations, and there are 5 variables. When you look at these problems in chapter 2, so problem 20, a car is traveling, 25, a jetliner, and so on, I believe I listed the answer in the correct order. So you would have to look at these problems here. You don't have to solve them. That's what I'm saying here. You don't need to solve these problems, but you need to look at them and see which of these equations would be applicable. Look at what they're asking for, look at what is given, look at what is left out that is not needed and doesn't need to be computed. And again, as I said, I believe they are in the correct order. Acceleration, write the words left or right into the blanks. In the top picture, so this picture here, and unfortunately it's just a little bit off screen. There we go, it's a little better. Write the words left or right into the blanks. In the top picture, the drag racer moves to the right. The acceleration vector points to the left. In the bottom picture, the speedboat, so there's a speedboat here. There we go. So the speedboat here moves to the right, and it accelerates to the right. And that's what you would have to write in here. And these 2 drawings are from the book. Horizontal component Vx. In the absence of air resistance, how does the velocity's horizontal component Vx change during projectile motion? The horizontal component Vx remains the same. The object, as it's moving across, and by the way, this is from chapter 3, as it's moving across in this upside down parabolic trajectory, gravity affects it, and that slows it down on the way up, and it speeds it up on the way down. But horizontally, as it moves across, if there is no air resistance, if there are no other forces, then there is no acceleration, and the horizontal velocity component stays constant. Sorry about that. I almost stumbled here over my own sentence. Okay. Acceleration also from chapter 3. Is the acceleration of a projectile equal to 0 when it reaches the top of its trajectory? If not, why not? Notice that I just about give the answer away to my first question, but then you still have to explain why it is it not 0 at the top of the trajectory. All right. Let's see, question 7. I believe for this one I'm gonna give all of it away, so you may watch this one here on density and pendulum, and this is playing with numbers that you get a feel for. Well, these are significant figures, these are the units attached to it, that when it comes, especially when we do lab experiments, measurements, we come across measurement errors, we come across outliers, and determining the median or the average. So I'm just going to give these away when you look at these here. these two here actually are grams per cubic centimeter. Apparently I measure something there, the density of objects in there. These must be some kind of metals I measure in there. This one here is the acceleration due to gravity measured in these videos. As you notice in the book, gravity is given as 9.80 meters per second squared, which is for the lower 48. That's what physics books are written for. In Germany, by the way, it's a 9.81 meters per second squared. In Alaska, when we do the experiments in the lab, we're actually aiming for 9.82 meters per second squared. Notice that these two results that I apparently measured here in my videos are actually pretty good. In a moment ago, I mentioned 9.9.9, but I also said meters per second squared. Notice that the unit attached to these numbers is centimeters per second squared, so obviously that's why it's 983, 981. Plus minus 4, plus minus 5, that's the error attached to this. Occasionally, I mention also something like this here. Note that this reuses a previously stated unit or statement. Usually, I don't do that all the time, but a few times. When multiplying or dividing measured data, their percentage errors add up. And there is actually a more complicated formula, but we'll see which one we're going to use. Within a conclusion, the measured result and the theoretical accepted result are compared. The percentage error explains why the two results are not exactly the same. Again, I'm just giving these away here, but you can also watch the video. Typical random errors could be produced by, let me see one moment, the spring scales and the measuring tapes limited accuracy, and again that's actually from the video. And now I have to see how I get that. There we go. There we go. Typical systematic errors should be produced by not zeroing the spring scale correctly, and then if amongst several similar results there are results that are obvious outliers, they should be discarded. This is actually more about measurements. Notice this is also an extra credit question. Yep, there it is. Extra credit question. So that wasn't actually in the book. It was that extra video that I posted, but again I actually gave the answers away for this one. And that was the recording for the pre-unit assignments for Unit 1. This is the recording for the Unit 1 homework quiz. Unit 1 is about the kinematic equations, so motion mostly. Alright, first one is an extra credit question. You don't have to attend class, so just answer these here to the best of your knowledge. Question 2, physics content and objectives. Read through these here. They're also posted in the unit itself. And if you read through them, I think they all make sense, so you should check all of these. Physics problems. So this is a guide how to do physics problems, and if I didn't make a mistake, then the way they're listed here are already in the correct order. So you're looking at a problem, you first understand what it's saying, then you identify and label the variables that need to be determined, then you identify and label the numerical variables that are given in the problem, identify and label implied information, discard extraneous, then identify and label the variables that are determined here is the second one here. I need to point that out because you have to figure out what is it actually that they want. So the second one obviously is very important. I guess I have to understand my own language here. And then so on. You can read through this yourself here at the very end. Make sense of the result and check if these results are reasonable, or that particular result is reasonable. All right, this one here is kind of a guide on how to look at problems and look at the language that is listed in there. And I listed a bunch here. You don't have to do these. You might have to do some of them at another time where I will do them in class. But I just want to point out that a number of them are using the same kind of language. And again, I believe these are in the correct order. So you have here all these kinds of problems here: basketball, skier, blood, drag racer, cheetah, and many more. And they all say from rest. Notice that I highlighted this one here. And from rest implies that the initial velocity with which they're starting out is 0 meters per second. They don't say so, but they do say from rest. And this is what it means. So that's kind of like in the previous one, steps 1, 2, 3, 4, something like that, where you have to look at the implied information. For these kinds of problems, they say something about freely falling. Freely falling is something that we like to use. That we like to use in physics to say that something is just falling without air resistance, and just G 9.80 is acting on the object. Notice that there are two answers over here that basically say something really similar. So there's A equals negative G, so negative 9.8, air resistance is turned off. And then the next one actually says there is no air resistance. If you look a little bit at the language here, choose this one here to be answer B, and this one here to be answer C. So any problem involving shooting, throwing, jumping, and the like, unless otherwise mentioned, is assumed that there is no air resistance acting on the shot. All right. In chapter 3, we will come across things that we have horizontal and vertical motion. And when it says horizontal takeoff, that means that as it's horizontally taking off, whatever that is, that means that there is no motion initially in the vertical direction. And so therefore the angle with which it takes off is horizontal, which of course is 0 degrees. And then the velocity in the vertical is 0 meters per second. That's what the horizontal takeoff means. And then please look at the other ones that are listed here. I might go back and actually reword these two a little bit here, B and C, so that it's a little bit easier to distinguish between them. All right, let's see the next one. So in these chapters here on kinematics in 2 dimensions and 3 dimensions, unfortunately, we have these 4 equations, and then they double up, because then we have the 4 equations for the horizontal and we have them for the vertical, and then we combine them, and then there is the Pythagorean in there. In any case, here are these 4 equations, and actually I claim, besides that there are 4 kinematic equations which contain 5 variables, and here they are. I claim that these first 2 equations, you're actually familiar with them. This one here and this one here, at least partially you're familiar with them. And so let me show you. You're driving at a certain speed, 50 miles per hour. Then you're accelerating, let's say at 2 miles per hour per second for about 10 seconds. Okay? So you're driving at 50, you're accelerating at 2 for 10 seconds. 2 times 10 is 20, plus 50 is 70 miles per hour when you're done accelerating. And that's where that equation is coming from. Not that you use it when you're driving, but you are kind of familiar with that. That's what you do. That's what happens. And the same thing actually when you're braking, in which case that acceleration here would be negative. The other one here, this one actually has the average velocity in there. So you're driving at a certain speed, 60 miles an hour, then you accelerate. Notice actually the acceleration is not part of this equation here, but it is implied that you actually have accelerated in between here. So 60 miles per hour, and then you have accelerated to 80 miles per hour. Of course, that means that the average velocity, this one right here, is 70 miles per hour. It has to be expressed rather strangely here, because how do you find the average between 60 and 80 in a mathematical formula? You can say average of 60 and 80, but how do you actually do it? Well, you add the 60 and 80 and then divide by the total number of velocities that you played with, and that would be 2. So 60 plus 80 divided by 2, there's the average of 70. And then the equation actually becomes something really, really familiar. Distance equals average velocity times time. Well, you're driving 70 miles per hour for 6 hours, and you have covered 420 miles. You're familiar with that. That's what I mean with these two equations, that they are kind of common sense. We are actually using them even though we're not aware of them. And then look over here. I think I defined them rather similar. Notice actually this one here uses this previous statement. I think both of them here take on answer B. And then this one here is perhaps something new. This one actually is kind of what I just talked about, distance equals velocity times time. And then we have to figure out in class, what does that mean here? 1/2 acceleration times time squared. Why is there a time squared? But I say that over here, that is actually kind of derived. And then the last one is actually totally derived. You're quite unfamiliar with that one. By the way, we will encounter this equation right now in these chapters, and then we will encounter it in a slightly different form when we talk about energy in a later chapter. All right. This one here, I want you to look at the posted problems that I have computed on YouTube, as well as that I have a certain script for it. In the script, I do the algebra, but I don't plug in the numbers. So you have to do that yourself. So you have to plug in the numbers and see what you come up with here. The way I word it here, though, is almost a dead giveaway. I mean, here it says, Chapter 2, Problem 16, look it up, whatever that is, and the acceleration is 0.97, match it up with the units. Well, it says acceleration right here. Well, that must be this one, meters per second squared. Or here it says final velocity, negative 7.1, well, that must be meters per second. Or here it says distance, well, that must be meters, and so on. Or here it says time, well, that must be seconds, and so on. So it's almost a dead giveaway, but I still want you to look at those and calculate them as well. Quite a bit, but you know, you can just check them off and compare them and do that rather quickly, and then go back and actually do the problems. This one here, these here you actually have to do, so you have to look at these here. So look at, let's see, Chapter 2, I think it says that over here, or slightly off the screen. So Chapter 2, these first few problems here, problem 12, 21, 39, there they are. And then down here, Chapter 3, problems 5, 29, calculate them and plug in your answers. Okay, question 8. Question 8 really looks more complicated than it really is. Basically, just go into the book to one of the chapters that is assigned, choose a certain problem, doesn't have to be the spacecraft problem, it's probably already taken up, and type that in here, and then answer that algebraically, so do the calculation, and type it in here and put it on the discussion board as well. All right, let's see. This one is the extra book, the Bloomfield book, how everything works. So you read through a chapter and then you see which of these are mentioned. So when balls are falling, there's probably weight involved and gravity and acceleration due to gravity and velocity, probably these kinds of things. Probably force and acceleration, probably not resonance or interference. Those are from waves and sound. All right, this one here, question 10. That's the mechanical universe. There are usually 2 or 3 of these 30-minute videos that you have to watch, and they're very instructive on physics. And you have to put these quotes in the correct order, and notice that I give part of it away here. So I say the Greeks is the first quote, so here's the number 1, and then you have to figure out where are the other 3 fitting in here, which one is the second or third one. I believe they were in the opposite order, so it's like this one is the first, and then this one is the second, third, fourth, and then the other one that I give away is that we have discovered is the 5th quote, and there it is, 5th, and then 6, 7, 8. Oh, I'm sorry, it probably is 6, 7, 8. All right, and then there's an extra credit question here, and then there is another extra credit question here. All right, and that's my recording on the Unit 1 homework quiz for the kinematic equations chapters.